So let's think about some examples where the quantile regressions can be used, um, can play an important role. The first example is the minimum wage law. So we are interested in the effect of an increase in the minimum wage. These days, this becomes a very hot topic, and I'm not talking much about the politics or the labor market, labor economics related topics, but only the technical aspect of this issue. So the main problem of the minimum wage, the effect of the minimum wage is that most of the workers are not affected by the minimum wage. So there are some portion of workers, low-skilled workers, who are affected directly by the minimum wage. But for example, I don't know. I don't know what is the minimum wage right now. Uh, I'm not. I think increase in the minimum wage would not affect my employment or my wage. So that means it is only a small portion of workers who are affected by the minimum wage. Then, if you look at the mean, if you consider the effect of the change, the policy on the average wage, its effect will be really small. However, instead, uh, for example, only suppose that only bottom five, like low skilled workers, 5% of workers are affected by $1. And then that means if you calculate the mean, the effect looks like $0.05, which is really small, but it is not so small to these workers. So instead, then in this case, a good method is using the quantile regression at 5%. So use the 5 percentile, then your result will be your estimate will be close to $1 because you are looking at the effect at the bottom 5%. So that is a clear example. It shows clearly why the quantile regression can be useful in this case. Similar examples include other like cases like capital income tax. Also, this is hot these days. So capital gains will be taxed a lot, but most of people are not affected by that. Then you cannot use the average as a measure and see your salary limits. I don't know if there is any rule change, but also, I see today from the New York Times that CEO salaries are increasing too much. So it's an interesting topic, but the point here is in these specific topics, we are interested in the tails, not in the mean. Then quantile regression is your choice. And returns to education. Second example, returns to education. I have been using this example all the times. So think about this. And earlier we considered the mean regression. So then we estimated the average return to education. So if you attend school for another year, then how much your income will increase. And the assumption is that we are calculating the average, or we are calculating the return for an average student. It does not look at the smart student or a stupid student. But of course, we know that the effect of the education would be different across different people. So smarter students will gain more from attending additional school, but dumb students, less smart students will not gain a lot from, say, my lecture. So if you do not get any new understanding from my lecture, it is not my fault. It's you are think where you are in the distribution. So the effect of the education may be different, and by considering the quantile regression, we can look at the different returns to education at different quantiles. If you consider 90 percentile, for example, then you are going to estimate those who have the effect on those who are at the top 10%. On the other hand, if you consider tau equals to zero point 0.1, then you are looking at the bottom 10%. So you can study what is the effect of a college degree on the smart students or less smart students. So that's another interesting question. And in this case, the point here is the dispersion or the heterogeneity or inequality. So the mean, there is only one mean. So you cannot compare the mean to another group. But by considering multiple quantiles, you can study the inequality across different types of students or types of individuals. So that's another example where quantitative regression can do something, can do some good things for you. Here, third example, infant growth chart. This is, I included this as a as an example because I work on this, and also I'm interested in my son's growth chart. If you have a son or daughter, if you have a kid, then you know this. Say my son is about like say 42, 41 pounds, 42 pounds. He's now like 5 years old and a half. So I'm wondering how big he is. Then quantile regression will help you. So if you enter your kid's weight or height on website, then it shows you the percentile. Like say, my son's height is 50 percentile and weight is about 60 percentile. I did not check it recently, so it may be changed, but it clearly shows where you are going. So the absolute value is hard to interpret. I don't know what, like you may have no idea how heavy a 42 pounds 5-year-old kid is. But when I say he is 60 percentile, then okay, you can understand. Oh, he is on average slightly above the average, so he's doing okay. So the quantile, by using the quantile, it tells you a better idea of where you are, the relative standing in the distribution. So whether you are on the higher side or lower side, something like that. So this is another example where the quantile regression is useful. Okay, and I summarized that in here. So then comparison. So why do we need to use, why you may be interested in the quantile regression? First, as I said, you may be interested in the dispersion or tails. I explained earlier. So the mean and the median, the mean is the measure of location. It only captures where you are, where the center is. However, you may be interested in the variance. So mean and variance always move together and they complement each other. So if you're interested in variance instead of the mean, variance regression does not exist. Calculating the variance, conditional variance in the regression is not easy. There is a theory, but it's not easy to handle. Then instead of considering the variance, a nice alternative is considering different quantiles. And it's much easier to interpret. And so in the examples of income inequality, financial risk, quality control examples, say when you make a say think about this. So you are manufacturing this Coke, then it has to contain 12 ons. But if your products have 10 ons or like 20 ons, then your quality is a problem. Then in this case, dispersion is the main problem. Anyhow, if dispersion or the tails is your main focus, quantile regression can be your method. And second reason to consider the quantile regression is because of the outliers. There are a lot of outliers in economic data. For example, if you look at the stock market these days, Tesla is crazy. Tesla is on a stock of the not in the world. It's an outworldly stock. Similarly like Apple, Microsoft, Amazon, Google, they are exceptional. Uh, they are so the distribution is very much skewed. While most of the stocks fell last year, say fell due to the COVID pandemic, still those top big firms have performed well. So then these big firms are obviously outliers, right? So then these outliers cause big problems on calculating the average. So I will show you later why this is a problem, but it is well known that the mean is very much sensitive to those outliers. But quantiles or the median are very robust. Quantile does not change uh, by small number of outliers. So this will be useful if you are worried about the potential problems due to large outliers. If large outliers contaminate your result, then the quantile regression could be a good alternative. Mathematically speaking, if the variance is infinity, then you cannot apply the mean regression. So if the variance is infinity, then one of the assumptions for the inference for the asymptotic normality, the central limit theorem, fails, so you cannot apply the standard method. In this case, quantile regression still works. That's interesting. And here, also another interesting example is that quantile regression may be useful in identification. Think about this. The mean is calculated this way. You sum all the observations and divide by the number of sample. On the other hand, if you calculate the distribution function, say you would like to estimate where is the median, say, then what you need is not the exact value of the outcomes, but if the median is 0, what you need to know is whether the outcome is above 0, or below 0. So if you observe 10 observations and 5 of them are positive and the other 5 are negative, I don't know the exact values of those observations, but if you know their signs, 5 positive, 5 negative, then you can say that the median is 0 without knowing the exact values. Of course, it could be slightly different from 0, but approximately not wrong. However, it does not imply, but in this case, you cannot do anything with the average. Average cannot be calculated at all. So, then let's put it this way. When you observe 10 observations, what you need is to calculate the median. You only need the fourth smallest observation and the sixth smallest observation. Fifth and sixth smallest observations. So if you observe these two guys, and then median is in between them. That's all you need. So you need less information to identify the quantile. Therefore, it is more useful when you have limited information. Examples, more concrete examples. Top coding. In real data, privacy, protecting the privacy is a big issue. So for example, if suppose in your survey, you have to ask the income to, say, Bill Gates. I don't know how wealthy he is, but if you put his true income in the survey result in the data, then everyone would know that this guy is Bill Gates because there is only one person who makes that much money. And then in that case, the privacy was not protected. Therefore, in most surveys, the income is top coded. For example, if your income is more than a million, then just simply answer like this. I don't ask you the details, how much, whether you are 2 millions or 1 billion. But the answer is only 1 million or more, and it is shown as 1 million. And then it is enough to calculate the median or many quantiles. But with this, you cannot calculate the average. Another example, duration model or survival analysis. Say, if I suppose that I had a say a disease, say COVID, simply. I suffer from COVID, and then researchers study how long it takes to recover from COVID. Then suppose that I suffer from the disease and say I die on the second day. Then I die before I recover. So that means I am estimating the time to recovery, but I do not observe more than 2 days because I died. And similarly, like for example, another example. So duration of unemployment. Unemployment duration can be studied using the unemployment benefit data. Like so, when you lose a job, then of course you will be applying for unemployment benefit, and then there must be data of the on the unemployment benefit payroll. So then you can calculate how long it takes for a person to find another job, the next job. Say a person has been on the payroll for 3 weeks. That means the person got a new job after 3 weeks. So then you can calculate how long it takes to get another job. The problem here is the unemployment benefit is given only up to 40 weeks. So more than 40 weeks is not observed. Then it's similar to top coding. More than 40 weeks is observed as 40 weeks. Still, it does not matter if you consider quantile regression. This is sufficient information to identify quantile regression. And sensor regression is similar. Say, for example, working hours. It is an important topic in labor economics. You want to study working hours. But usually it has a minimum at 0 and maximum at, many people have 40 hours a week because that is the law. And hourly wage is also similar. It is censored at the minimum wage. So 0 or minimum wage and then distribution. So it is censored. So then mean is not easy to calculate. Okay, I think I will call it a lecture. We will continue to the next part in the next lecture. See you later.